Hello, Calc. The area of a planar region will inform and entertain us and challenge us on 2/9/17 after Thursday's class. It looks a little bit like I'm departing from integration, but I promise you it's going to connect. It won't connect very well tonight, but I'm setting the groundwork for something important and big. All right. So I was wondering what the area is of this planar region, and it's under this curve, y equals negative x squared plus 5. So let's see what that would look like. Well, negative x squared would be a inverted, it'd be a frowner, and the plus 5 will just raise it up like that. So looking at the basic shape of this curve, I was wondering what is the area under this part of it between x equals 0 and x equals, say, 2. So I'm looking at this area here. All right, the way I'm going to approximate that area is I'm going to divide it into 1, 2, 3, 4, 5 rectangles. 1, 2, 3, 4, and 5. All right, those rectangles are going to, well, right now they're not exactly rectangles, so I have to decide how to make them a rectangle. So what I'm going to do, I see if I've gone from 0 to 2, and there's 5 rectangles, 2 divided by the 5 rectangles tells me the width of the bottom of each rectangle. So this would be 2/5, then there'd be 2/5 more, so this would be 4/5. And this point would be 6/5, and this point 2/5, 4/5, 6/5, 8/5, and I didn't leave myself much room to write those numbers, so I just used those lines to point to that. So what I'm just meaning, this is 2/5, the x value, 2/5, 4/5, 6/5, 8/5, and 10/5, which is 2. All right, so I am going to take this rectangle and go to the right side of it. And I'm going to put a point there, and I'm going to make a rectangle with that point. Then I'm going to go to the next rectangle and take the right side of it and make a rectangle out of that. And I'm going to go to the right side of the next, and the next, and the next. All right. So do you see that the area under these 5 rectangles, the way I constructed them, will be an approximation? Of course, it's going to be off because these several sections are not going to be included in those calculations. But it'll get me in the right direction. So how would I calculate that? All right, well, looking at the first rectangle, it's 2/5 in length, or width I'll call it, but what is its height? Well, that's that dot there that's representing the right side of the first rectangle is on the curve. So I can find the height by finding the value of that dot, and that dot is at 2/5 for x. And the curve is this. So if I put 2/5 in for x, that should get me the height. That, putting 2/5 into this equation, gives me the height of that rectangle, and 2/5 is the width. So then I'm going to do that again, and I'm going to add to that 2/5, and this time the height is connected to this point, and that's where the x value is 4/5. So I put 4/5 into that equation. And then the next one, I have 6/5. And when I get here, I'm still here. I get 8/5. And lastly, I'm going to have the last box where the x value is 2. So I have 2/5 minus 2 squared plus 5. Alright, so all of those barely fit in the screen, but when I add those all together, which is a little bit of a pain, it comes out to 6.48. Now, do we anticipate that being lower than the true area or higher? Alright, I kind of alluded to that earlier. Because these rectangles are below the curve, it is going to be a low approximation. So 6.48 is a lower approximation. And I'm going to call this it's going to be a lower sum. And it was made, in this case, from right endpoints. Remember when I constructed my rectangles, each one was using the right endpoint. So, depends which way the curve is bending as to whether right endpoints will be lower or upper sums, but in this case, it's definitely a lower sum. Alright, so now, guess what I'm going to do? Surprise, surprise. I'm going to go and do the upper. I'm going to do the left endpoints, which is going to give me an upper sum. So, here's my curve again. Let me sketch in 5 boxes. 1, 2, 3, 4, 5. Alright, again, this is 2/5, 4/5, 6/5, 8/5, 2, and this is 0, of course. Excuse me. So, this time I'm going to construct my rectangles by using the left side, and the left side of this box has a height that's there, and I'm going to go across like this, and then the next box, the left side is there, left side, left side, left side. So the calculations I'm going to make this time are going to be slightly higher than the true area under the curve. So what will that look like? Alright, so the first box, the height of this box is when I put 0 into the equation. And remember the equation was y equals negative x squared plus 5. And the width is 2/5. So I have 2/5 times negative 0 squared plus 5. And I'm going to add to that the next box. So the height of this one is found from the left side of the box, and that's where you put 2/5 into the equation. And that's squared plus 5. Then the next one, right here, I'm putting in 4/5 into the equation to get the height. And so on and so on. Alright, so I've got this 1, 2, 3, 4, and I need to put 8/5 in next. And that's where I finish, right there. Alright, so all that ended up to be 8.08. So this was an upper sum because my rectangles went above the area a little bit on each one, and I was using the left endpoints. Alright, so now I'll make a statement, and that is I'm going to take the number from here, the 6.48, and tell you that that's going to be less than the true area because it was a lower sum, and it's going to be, the area is going to be less than 8.08, which was the upper sum. So how could we improve on these numbers in these for this equation? Well, we could put in, instead of 5 boxes, we could put in 10 boxes. And if you drew 10 boxes instead of the 5, you see that there was much less area that was above the graph. The graph, all the box tops, we'll call it, will hug the graph a little closer and will give you a better approximation, both on the upper and, or from, this was the left endpoints and the right endpoints. The lower sum, so the lower sum will get closer and the upper sum will get closer, and it'll sort of squeeze into the true area. So I just want to leave you with that thought, and you'll be doing problems that are related to these boxes. So bring this written down in your comp book so you'll be able to set them up. The equations we use and the little divisions that we use might be a little less cumbersome than this one, but the concept will be the same. So, till that moment, see you later.